Go ahead, whenever you're ready.
Hi, I'm Alex Doucette. I'm majoring in electrical engineering.
Hi, I'm Rebecca Gabrew, and I'm majoring in civil engineering.
Hi, I'm Gregory Hebert, and I'm majoring in journalism and professional writing.
Hey, my name is Brianna, and I'm a high school year senior from AMSA.
And this is our project, the Command Center, which we worked on in partnership with Collins Aerospace and Dell. So our project is broken up into three separate parts: the project overview, our methods, and then the reflections and our industry insights. So our project, the Command Center, is a menu-based input device that uses a bunch of different applications, including a Wi-Fi connection, in order to send strings of commands to multiple devices. So our device is the menu, which allows, so the menu can be edited, and you can use the mouse, not the mouse, use the joystick to move between the options. So the user requirements, it runs and connects to the computer using the MS4 Launchpad. It uses the LED screen, the joystick, and the button from the Booster Pack MK2, which is connected to the main board. And then there's also a Wi-Fi booster pack, which allows the Wi-Fi connection, which helps us connect to Adafruit, which is how we send information packets. So we designed this product specifically for organizations or an industry, really any place that would have a wide array of devices that do numerous things and would benefit from having all of those commands in one singular place. We really wanted something that our partners, Dell or Collins, could use, but we wanted to also contain the functionality of being able to do a lot of different commands.
When we first began the project, it was just about trying to get an idea. It was just about trying to get ideas and integrating the advice from Collins Aerospace and Dell Technologies. We were able to make a plan or an organized way of thinking in order to gather our thoughts. This helped make a clear goal or small victories for something larger. What started with an idea became something real, and through testing the code and refining it, we were able to achieve the final product.
So this is what our end-to-end block diagram looks like for the main program loop that we settled on. So the first thing that it does in any program loop is it reads the position of the joystick and the state of the button so that we know what the user is interacting with in any given program cycle. Then it needs to check to make sure for rising edges or changes in those states. So that if you, for instance, didn't check for that and you held down the joystick in the down position, every single time it would run through the program loop, which runs multiple times a second, it would register a down command if you didn't specifically check for that first initial instance. But because we were checking for that, it only does the processes when you first initially do the presses, and that is when the user is intending to actually execute a command. Now that we're checking for that, you can see that we have our three decision choices, which are the joystick up, joystick down, and the button pushed. If none of those happen, we just go back to the start of the loop. But if we do have one of those happen, joystick up moves the cursor up, joystick down moves the cursor down, and pushing the button sends the selected item over Wi-Fi, which you can see we have broken up into a four-step process where we connect our router to Adafruit. We subscribe to the specific feed that we're going to send data through. We then send the data that we're trying to send through that specific feed, and then disconnect so that we're not staying connected for the entire time. And then once we do that, we're just going to tell the user that the string is sent, and then go back to our main program loop so that we can continue checking for new information. So here we have just a picture. It would be a video, or I'm just going to not run it for now, but basically you just have the joystick movements can control the menu positions, and then if you press the button, it will send the message. And you can see on the other side, we have the Adafruit I/O setup where I have the specific feed where we're receiving data from our screen.
So over the course of this project, for me personally, I definitely got new experiences, and I know that everybody else also like was able to grow from this experience. Whether it was being more socially aware of teamwork and just getting better at communication, or just learning code. Um, in the future, if there was more time, there definitely would have been more add-ons, such as numerical data being sent. So instead of command, there would be numerical data, as well as a warning screen, or just like a reassurance, and are you sure, almost, to make sure it's what the user wants, as well as a password, or it's almost like a video game cheat code, allowing you to send commands moving up or moving down, left or right.
Since our project is based off our industry partners' advice and insights, or the project process, I will now go over them. So this on this right, you can see is the V model, which is a representation of the process flow, which is a necessary series of events that is needed to define or make checkpoints. So basically, breaking down our project into smaller steps to make it easier to accomplish. On the right, since the V model. On the left side of the V model, it's mostly about making an idea, finding its requirements, and making that detailed design to eventually be implemented into a prototype, which is at the bottom, at implementation, where you have the physical prototype, and then when you move on to the right of the V model, you move on to testing, seeing if it fits the requirements, and customer service, which is at the top of the V model, where it says operation and maintenance, where we don't deal with that because we're not a company, but it's mostly just making sure that the product keeps doing what it needs to do after the customer has bought it. We also applied some advice from our mentors, where they told us to ask for help early, so then you can learn faster and finish your part in the project earlier. They also told us to communicate our feelings after thinking about it, and in private to the other person we feel those towards. But because if we said it in the moment, we could have so much emotion behind it that it clouds the effectiveness of telling the other person what needs to happen. And they also told us not to be conscious of other people's reputations, because your bias could be the downfall to the team dynamic. So it's best to not think about that. Our industry partners also talked about how to make a stable project, and that is represented with the stool model, which is shown on the right. A stable and good project is balanced from equal schedule, function, and cost. Schedule being what to do and when to do it, function being what the project actually does, and cost being the resources you have to complete it. And what is the rest is just what our industry partners company, that's how their companies work. And that is all.
Here are references, and that's all we've got.